Yes, we're back. All right. So, checking it out. Today we are going to continue this discussion. We've already looked at the logistics of how today's going to operate. We're going to look at symmetry and functions. You're going to write down this and this. You're not going to draw these graphs unless you absolutely want to. Even if you absolutely want to, I don't want you to graph them. I want you to really roughly sketch with some things in mind. I probably wouldn't even commit to this, just so you know. Bless you. Okay. We were talking symmetry. Do you guys remember that conversation where we said if you replace y with negative y or x with negative x, it makes an equivalent expression? And I kind of went over it pretty quick because I knew in my heart of hearts that we were going to have a more detailed, more reasonable, like meaningful conversation about it in the coming days. And lo and behold, here we are. I have 3 graphs here. Would you agree? Okay. We haven't said symmetry like we talked about it the other day. What does it mean for something to be symmetric? What physical object do you think of if you're thinking symmetry? I like what you did. Are these symmetric? Roughly, we're going to say yes. If you had to say it did something, this is a mapping. This would be a function if we're thinking in math. What sort of mapping would get me from here to here? A reflection, right? There's a line here where I have symmetry about it. Okay, well, I gotta think this out. Are these symmetric? Okay, now there's a couple ways. Can you just have a single line? No, my thumb would be wonky, right? It wouldn't fit. But you can think of it as a single rotation if you want to. But if we're thinking in math, can you think of a single rotation? It's like reflection and reflection. 2 reflections, sorry. Okay, doesn't matter what I'm looking at. There's symmetry there. Would you agree?
Yes.
Maybe there. I'd struggle with this 3-dimensional space in my head. Okay, does this guy have symmetry? The first one, the red one, f of x. Is there symmetry on this graph? You think so? So this one can be challenging if you can't see it straight up. I've included like values and details here. Let's just do a little bit of thinking. 0, 0 is on this graph. We can all agree, I think. Again, you do not have to draw it. We're going to make some big connections just with the picture, and we'll summarize it shorter. Okay, 0, 0, in my mind, looks like the point that we kind of deal with my symmetry. Somewhere around that point, because that's one that's on wherever. Okay, pick a nice point on this graph. It doesn't have to be perfect. We're going to estimate. 1 point something and negative 4 point something. Are you guys cool with that? Okay, so I'm just going to say, instead of doing that, I have x and a negative y. That's what that ordered pair will look like. Everybody cool with that? Is there a matching point on the other side that wants to be maybe just rotated right around and it would land on it? So what I mean by that, if it's not clear, see if I can get my hands to do this. If I take this, could I just rotate it and land on itself? And it'll happen literally at every single point. There's some sort of symmetry going on here, but I want to really pick out this other point. I'm just going to follow along the function from left to right, as we always do. You tell me when I get to what you think is a symmetric point. Okay, deal. There was a point there. How would you express this point? What happened with the values? Because it's the same x, it's negative 1 point something this time, and positive for, like, the same values, just the signs have changed. How have they changed? Some negative stuff wound up happening, right? Now, what I want us to pick out of this, and we'll get this here in a second, is that if I plug in, for example, x, this value, and we're going to write this in a minute, but don't write it yet. If I were to plug in x, f of x equals, what was it here when I plugged in x? So that's the x value. What y did it spit out of me? I don't need a number. Just tell me what I wrote down for that ordered pair. Negative y. Everybody cool with that? Okay. When I plug in negative x, what does it spit out? Okay. That relationship is going to mean something to us here in a second. All right. We're going to pause there for just a second. Let's switch to blue. Do you see symmetry on this one? Confidence.
No.
No, okay. Don't have to worry about it. No, there isn't any. Do you see symmetry in green? Okay, so let's do the same thing. if I were to plug in, I don't know, I'm just going to pick an arbitrary point. If I were to plug in x, that random x value, f of x, does it just spit out a y value? Sure. Like, it's weird to think about it because I have numbers and I should have taken the numbers off. But I plug in an x, it spits out a y. What happens if I plug in negative x? So instead of going over, it looks like 3 on my ticks. If I go up 3 and then go up, hey, is that the symmetry you guys probably saw? So when I plug in negative x, what does it spit out? Y. It's the same thing. These relationships right here are what we really care about. Notice we're not talking about any symmetry about the x-axis because then we wouldn't have a function anymore. It wouldn't pass a vertical line test. Are these easy to pick out? If I give you a graph and I tell you this is really well graphed, you think you can identify if there's symmetry? What if I give you an equation instead that's awful to graph and you don't really want to graph it? Would it be as easy, do you think? No. A graphical approach is pretty easy to see. An analytic approach seems like it might be harder. Spoiler, it's not. Way easier to do it analytically than it is to even worry about making the graphs. Can I erase these pictures so that our notes look the same? I don't know why I asked. I'm going to do it. Cool. So we have, how many types of symmetry did we just see? We saw 2 different graphs, right? And I'll tell you, we could make infinitely many graphs, but we'd only ever find those 2 types of symmetry when we're talking about functions the way we are. Now, we're going to sneak in some definitions. We want to consider this following question. When we're looking for symmetry, and I can even get rid of those, and I'm going to say to determine symmetry analytically, or I've used that word all the time. If we don't want to use analytic, what is the other word we use? What was your last year's class and kind of this class so far, honestly? So algebra was what I'm after. Analytic or algebraic. They're going to mean the same thing. To determine symmetry, and I'm just going to shorthand to sim, algebraically or analytically, whichever one you want to write. If we want to find symmetry, we will always start the exact same way. We will first evaluate f of, now I erased the pictures, so we're just relying purely on how good of a mental image you have. I plugged in x, I worked out f of x, and what was the other point I did? F of what? Negative x, on both of them, right? That's the same example we used. When you're dealing with these, first step is we're going to determine f of negative x. That's it. Okay. Once you do evaluate f of negative x, there's 2 situations that are going to possibly occur with this. 3 realistically, but we'll talk about the third. Okay. First option. We don't say necessarily that a function is symmetric with respect to blah, 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 because that's a mouthful. We use different language. We have, and I'm going to sneak in a definition, functions that we'll say are even functions. And then I'm just going to take a small space because I want these to be on the same line in importance. If we have even functions, your experience with language says, what's the other type? Odd functions. Only 2 possibilities that we're going to deal with. Now, realistically, there is a third, and we don't have to write it right now. It can be even, it can be odd, not like numbers like 2 and 3, but what's the third option? Symmetry about this or symmetry about that, or that middle graph that we just drew a cross through, was there symmetry? It could be neither type of symmetry, right? There's no symmetry. Okay, so in either case, these are super easy to work out. Now, if I give you nice and easy graphs, it might feel more natural for you to just graph it. And I get it. You can do it. However, we're not always going to get nice and easy graphs. If we have an even function, we have symmetry about the y-axis. It is that easy. And we'll see the algebraic test here in a second. Give me a shape off the top of your head, or in your margins if you need to, that has symmetry about the y-axis. You'll probably figure it out. There it is. It's a parabola, right? Cool little wordplay there that worked out nicely. If I take this and then here's the y-axis, I just go, hey, reflect it, and we get it, right? Now, very specifically, if you want to have a nice little picture, we can use a parabola or we can use a wonky shape. They don't really get super duper crazy. I'm going to use a medium crazy shape if you want it. You do not need this, but this is just a nice little tool to see it. Okay, for my symmetry, I'm going to do this. Didn't do it perfectly, but can you tell I attempted at least to do symmetry? Okay. I'm going to call this function f of x. Now, if I pick any x value, we always start by evaluating what? When we're testing for symmetry. To determine symmetry algebraically, we first evaluate what? F of negative x. So, assuming that it's just some number that is positive in my head, could this possibly right here be negative x? Sure, it doesn't matter where it is. Okay, if that's negative x, and I eyeball this out, would you agree then that this would be what value? X, positive x this time. What do you notice about the y values that correspond to my graph at negative x and positive x? Pick a number, don't care. What number is this? Sure, what number is this on the other side? Oh, can we make that more general? If you evaluate f of negative x, that's just going to say it's going to spit out a y value at you, right? What y value does it spit out on the other side? F of negative x would be exactly equal to f of what other value? X. Boom, you got it. If this happens, you don't have to graph it. And if you do have to graph it eventually, you now know that if this occurs in your function, you only have to do half of it and then just reflect it over the y-axis. You've literally cut out half the work in that problem. Okay, we'll do an example of some of these here in just a minute. That's even symmetry. Odd symmetry. And I'm not going to change colors, but I'll do the dashes. Odd symmetry, or odd functions, are going to be symmetric or have symmetry. And I use the word about, but it's fairly common that you're going to say with respect to. And either one is fine. I like about because, again, I'm lazy. What's your gut say? That is a natural choice, but I want you to think, here's a parabola, or part of it, and I'm going to reflect over the x-axis. Is this a function? So we can't even talk about the symmetry of a function that's not a function. That's I'm trying to trap you there, just so you know. That's intuition, I get it. Symmetry about, if it's not the y-axis, and it can't be the x-axis, any other really important parts? Oh, my origin. Okay, when we have symmetry about the origin, same thing. If you want a graph, I'll hook it up real quick. I'm not gonna make like super nice graph. This one's actually gonna be a lot lazier because it's harder for me to draw these. It is a beaut. There's my function f. I'm not even gonna call it f of x, I'm just gonna call it, I lied, it's gonna bug me. Okay. Anytime we're checking for symmetry, what's the first thing we're going to check? Or evaluate, rather? F of negative x. So, let's check it out and just see what happens on this graph. If I plug in f of negative x, that is me just saying, hey, if I go some distance over, like, I don't know, x to the left, it spits out this y value right here. If, however, I go x to the right instead, it spits out this y value. What is the relationship between those? They're the same y value, but something's changed. The signs, right? So just so you guys are aware, if I ever use it, the word parity, P-A-R-I-T-Y, instead of like a joke song, a parody. Parity is when you're talking about what sign does something have. So the parity changes right here. If I plug in f of negative x and I evaluate it, it just takes that same value and it just makes it negative. And this one's harder to see, but it's just negative f of x. If I say that f, we'll do an example before I just have to generalize it here. Does that seem super duper crazy? Okay, do you think sometimes it might be challenging? Okay, functions can be even, they can be odd, or they can be neither. Now, you may see symmetry, like if I think of a parabola, and this is where it's just going to get weird. I don't know what this is, but we're going to get rid of it. No, we're not. I can't close it. Okay. If we think of a parabola, and let's say that I just want this one. X, we're going to make this x minus 1 squared. We'll turn it on. Does this one have symmetry? Now, follow-up question. This graph looks like it has symmetry in the y direction, right? Is that an even function? Why not, Fern? Holy y-axis. That is symmetry about the line x equals 1. Is that the y-axis? No. So there is symmetry, and there's symmetry about a particular line, but because it's not the y-axis, this is not an even function. Now, there's benefit to this year for graphing. There's huge benefits when you get to calculus because less work is always better. Cool. Let's check a couple out. So example, and I want to know only one, it's really 3 questions, but even, odd, or neither is the only question that we're asking with regard to these functions. All right, let's see if we can get a crazy one. On example A, hate it. Anybody draw their A's like that? You used to? I like the way it looks, but here's what I don't know. If I write the word bad, like this, I don't know if I use this fancy serif A, I don't know if it has to do this, or if it does this. Because they both kind of look dumb in my head. Well, this one I've made that so that the top of my letter is consistent between the B, the A, and the D. This one, I honestly don't know. Just a fun fact. Fact. Anybody draw their F's like this? With that obnoxious line on the bottom? Probably not. You guys ever seen the word serif? Like, probably, if you ever, so you might not spend a whole lot of time like browsing fonts, but a lot of times you'll see sans serif on the end of stuff. Sans is French for without. Serifs are those little things that you add to it. So like Doctors Without Borders is only called Doctors Without Borders here. Anybody know what it's called literally everywhere else in the world? Doctors Without Borders. So it's an international organization that sends doctors to places regardless, like for war-torn areas, like they don't pick a side, they just go fix people. In the US, it's called Doctors Without Borders. Literally everywhere else in the world, Médecins Sans Frontières. Because it's French, sans without, frontiers, borders. There we go. Back to math. I have a lovely function here. We'll say its f of x is x cubed minus x. Anybody know what that looks like? I don't know, probably looks something like this, but I don't know how exaggerated it is. No idea. Don't care. Doesn't matter. I don't want to graph it. I just want to know if it's even or odd or neither of those things. Charles, you're going to hook it up here. If I want to check if a function is even or odd algebraically, I will always first evaluate what? Get real loud because I'm real deaf. Symmetry. So we're checking for symmetry. We need to evaluate something with this. Look to the very top of the screen. We always first evaluate f of negative x. Okay, so remember we've dealt with functions. We know how functions work. First step, no ideas going into it, f of negative x. Now, with a negative, the parentheses matter more and more and more and more because if you don't include them, you're done for. So let's check. Negative x replaces that one, cubed, minus negative x. Anybody see this and go, oh, crap. Some of you might. It's weird without a number. If you cube, or let's say you have a negative number, like, I don't know, x, and it's to the first power, what's its parity? Say it again. The same. It's negative, right? So remember, parity is just negative, or sorry, we'll avoid that. It stays negative. What about negative something cubed? still negative? How about negative something to the 5th power? Or 7 or 9 or 11, all those are still negative, right? So as we're looking at this, that's all that we really have to worry about evaluating. If I were to plug this in and do negative x times negative x times negative x, the result is going to be negative, and it's going to be x to what power? To the 3rd. Do not misinterpret what just happened. We didn't just magically drop the parentheses. We had to use that logic to see what actually spits out. Okay, what happens with this next one when I subtract a negative? It becomes plus x. Now, it may not feel like we've really done anything, and that's okay. Does that look exactly like the one that we started with? No. Okay, so right off the bat, do you think it's even? It would have to be the exact same. F of negative x would be the same as f of x. So let's just see some work here. This is always an awkward thing to do, but when I look at it, my first thought is, hey, I want this to be positive, but it's negative, right? Could we factor a negative out of it to make it a positive? That's a lot of language. If I do this, are you okay with what happened there? I factored a negative out, and then I would still do one more. I would make it that. You can see what I've done, or you cannot see what I've done. Okay, so let's just check this again. I want to try to make this look as much like the original as I can. What should I factor out of this term, and in turn all of them eventually, like it's going to have do all of them. What could I factor out to make this a positive x cubed like where we started? A negative 1, right? If I factored out a negative from here, this becomes a positive x cubed. What happens if you factor a negative out of this? Louder, Abigail? Good. Okay. Again, does it really feel like I've done anything to you? Huge immediate result. This is what I'm after. 30 seconds with your group. Why do I want to scream from the rooftops that, yes, I know the answer at this point in time? Talk it out. The question was, has this shown up anywhere else in the problem? Don't you dare erase. Has x cubed minus x shown up anywhere else in this problem? What is x cubed minus x? So let's just check this out. I've done all this because obviously I know what I want to get to, and it takes practice. I need equal signs too. Did I not have equal signs? Weird. There's a negative there, right? Yeah. Man, that's just negative. What did you tell me was special about x cubed minus x? Notice what just happened. We just showed that for any negative x you plug in, it spits out exactly negative f of x. If x spits out y, negative x spits out negative y. That is what's written on the board right here. F of negative x, did it eventually spit this out? So all of a sudden, once we have that, we know that this thing is odd. Odd function. Now, the purpose and why you would care about this. Right now, honestly, you probably don't. I'm going to pick 3 points real quick. I know it's going to be a smooth curve. What's the easiest point you could possibly plug in? You do not have to graph it, just so you know. Was that really offensive, what I just said? Okay. I will help you pick them up. You don't have to if you don't. Okay, all right. Check it out. 0, 0. If I plug in 0 to my original function f of x, 0 minus 0 is still 0. Everybody good with that? Okay, plug in 1. What's 1 minus... That's a terrible example. Let's pick in 2. What's 2 cubed? Minus 2? So I get the point 2, 6. And I'm just going to eyeball it. I don't care about scale, just so you know. That could be 2, 6. Let's get one more. If I plug in a 3, what's 3 cubed? 27 minus 3. Okay, so I'm not counting at all. I get roughly these 3 points. If I connect these with a smooth curve, as best I can, it's not going to be that good. Since it has odd symmetry, do I have to really do anything else? I know that all these points just reflect right across, right? Without any thought, I know that if I just go this far over, here roughly, and that far down, I get it. I can see that these points are just going to connect here, and we've cut out half the work. It will benefit you when we're graphing. It's hard to get used to. In calculus, it becomes so much more powerful of a tool. Should we do another one together before I ask you to do your own? Cool. Should we make the function uglier? No is probably the answer I would expect. But let's check it real quick. Wrong section. Because if I just make one up, it's going to be too hard. All right, so I love the function g of x this time. We'll get a little wild. G of x is exactly equal to x to the fourth minus x squared minus 1. I want to check to see if g has symmetry because assuming that I'm going to graph this or have to do something with it, I'm lazy. I begin always algebraically checking for symmetry by first evaluating what? G of negative x in this case. I'll never fault you for that, just so you know, JV. Okay, if you didn't catch what JV said, he said f of negative x because that's what we always use. I'm going to just make sure I'm consistent. Let's find g of negative x. If you take a negative number and you raise it to an even power, what happens? It turns positive, right? So let's check. This would be, and I'll plug these in, negative x to the fourth minus negative x squared minus 1. Now I just need to see what they spit out. Negative x to the fourth power becomes positive x, because negative times a negative times a negative times a negative. And what's the power still? To the fourth. What happens with negative x when I square it? So if I take too big of a jump here, are you okay if I just say that's just minus a positive x squared? Why didn't I distribute? If somebody's going to make a mistake, they're going to do this. Why is that wrong? One more time. So, possibly. My concern that somebody might get goofed up on is distributing, but what happens before you distribute? You got to square, right? PEMDAS says do the exponents first. Does this have an x in it? Is it going to change at all? Still minus 1. Okay, is there anything special about x to the fourth minus x squared minus 1? It's g of x, isn't it? That was where we originally started. So I'm just going to say that here, this is exactly g of x. And to summarize it so we can see it very clearly, would you agree that we just have shown that for any value, g of negative x is exactly equal to g of x? Means if I plug in a 1, it spits out 5. If I plug in a negative 1, it spits out 5. If I plug in a 3 and it spits out 12, negative 3 spits out 12. I have symmetry. Is that even or odd? Even. Now, again, if we wanted to graph it, which I don't really want to necessarily, I bet it's a really wide parabola, I only have to do half of it. Yo.
I don't understand how you're like getting rid of the negatives after you make it g of negative x.
So like between these two steps?
Like the negative x 4. How does that turn into positive x 4?
So let's check it out. The fourth power means literally this, which I would encourage not to write it.
Right.
But let's just do a little bit of stuff. What's negative x times negative x?
Yeah, positive x.
So x to the,
Second.
okay, times, what's this negative x times this negative x?
X to the second.
And what's x squared times x squared?
X to the fourth.
Because it's an even exponent, those negatives cancel. Like,
So you can write it not negative even before you do the exponent.
so not before, and that's an important distinction. Great question. Between these two steps, it looks like almost nothing changed. But this is what I've done between these two steps. Like we've actually expanded it and saw how the signs change.
Okay.
So,
I see now.
yeah, like it looks like magic, and that's my bad. I should annotate more. But that's happened here. It happened here as well. What you didn't see me do was negative x times negative x times negative x,
Yeah.
which would be x squared times a negative x.
I understand.
Yep. Cool. All right. Try one together, or try one on your own, rather. Cool. Let's find a icky one. That's a weird one, because that word has been around forever, but it's just more offensive, I think, now. People use ick here. What gives you the icks? Is that hit here yet? Okay, it has. All right. For some of us. All right. Us. I don't use it in my language. Let's find one more gross one. Oh. Cool. Last one. I have h of x, I'm telling you, is equal to the product of x and x plus 5 to the power of 1/2. Ooh. Well, best luck to you all. No. Now, really, none or no symmetry, but there just isn't any on this one. Okay. Can you guys tell that I did not get good sleep last night? Man, any idea why I didn't get good sleep last night? Rocket League Season 16. Golly, I was up to like 1 o'clock. Whew. Cool. Feeling okay? Feeling awful.
What's the battle pass, bro? Or the rocket pass?
Oh, I don't know. I use the Fennec.
Series?
It's a BMW.
Yeah.
Yeah. I don't know. I bought the Rocket Pass like 5 years ago, and I just get it every time now. Okay. We are going to pause here for the new stuff. I'm not going to give any homework. We're going to start a little factoring stuff, though. Briefly. Do you want to do a quick brain break of some sort? Do you have suggestions for a brain break of sorts? I wish Wordle were unblocked and we could play a Wordle together.
Let's do the one with the 4 categories, and you have to, or there's like, it's the same. It's a New York
It's like
Times
16
one.
words. There's 4 categories. You have to match which 4 words.
You have to like find similarities between the words. It's a New York Times puzzle.
I'm going to look at it before I commit to it.
Okay.
Okay. Not that I don't trust you, but I don't want to go into something that's going to take 20 minutes if I don't know it. You guys want to learn to count in Portuguese? You can say no if that's not a cool option. Okay, you don't have to learn, but I'm going to attempt to at least teach you. All right. So, we're going to, do you prefer the word flowchart or roadmap? Okay. So, let's make a quick flowchart, and I would turn a page because we have one more comment to make about this section, but it's easy and it's quick. Somewhere that you will be able to reference this will continue to grow. We need to remind ourselves on how does one factor polynomials. All right, poly is what? Many. Nomial is a harder one. These things are of the form where you have x to an integer power plus x to a smaller integer power, so x to the 8th plus 6x to the 4th, blah, blah, blah. As long as they're integers, we're fine. Positive integers. Okay, so we need to factor polynomials. Now, if you want it, you don't have to have it, but in case you're like, oh man, I don't remember what a polynomial is, it's these. F of x is equal to a, I'm going to say a sub 1, or a sub n rather, x to the n, plus some other term, which I'm just going to use a sub n minus 1 to indicate this is just a different number, probably, times x to the n minus 1, and dot, dot, dot. Eventually, you'll get all the way down to a sub 1x to the 1. I don't want to write to the 1, plus some constant, a sub 0. That looks awful, I imagine. Do you agree with, like, does that look nice? Okay, check it out. It is. Your brains just haven't generalized this yet. Does this look scary? 3x to the 5th, don't write it, you don't need to, plus, I don't know, x squared plus 1. Does that look scary? Same thing. Just I'm using general. So some number, some power. Some number, some power. That's all we're doing. Now, if you wanted to, and it looks stupid, that's probably not the right word to use, could that expression be written like this if I wanted to? And so forth and so on. Like, why would I include these though, yeah? Okay. So, when you're factoring, you're solving those things, and really you're just breaking it down. First and foremost, what does it mean to factor something? We're going to start like 10 years ago. factor 8 for me. How does 8 factor if you were to build a factor tree? 2 times 4. Boom. You've given me 2 things that multiply to do it. That's not the prime factorization, which is what we'll be after. 2 times 2 times 2 would be the all the way down the tree. That's factoring. It's the exact same thing that you guys have done forever. Now, when you get a polynomial in this form, always, 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 and I got to think of how this is going to be with a flowchart. Always, 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 we start with the same thing. And I'm going to number them because I think I have to, otherwise I just won't be able to keep it straight. Step 1, and maybe, I don't know if I like the numbers or not. GCF, always, always, always. What is a GCF? Okay, greatest common factor. Now, I changed my mind, you don't have to change yours. I will make us a nice one so that like it's a, I like Canva, so I'll probably do it on Canva. But once you've done GCF, either there was one or there wasn't. Doesn't matter. You're then left with only a few situations. One possibility is that whatever polynomial you're looking at, whether you took a GCF out or not, is how many terms it has. If it has one term, you can't factor it. Like, you can't factor x or x squared in a meaningful way. Everybody okay with that? Okay. What's more than one term? 2 terms is the right answer there. What do you call a polynomial that has 2 things? Binomial. If it has 2 terms, you might, and you will in fact, have a binomial. So we've checked the GCF, and now we say, is it a binomial? If it is, there's 2 situations that you need to worry about. The first of these, and you can add the like labels and stuff if you want them, or the circles or whatever you call it. First thing is it a difference of 2 squares? Do you guys remember what a difference of squares looks like? Do you want an example within like right here, or do we just want the big list and then we'll cover everything? Okay. What's a square of x? Okay, good. So I'm just going to call it x squared. What's difference mean? Okay, give me any square number. Sure. Do we have a difference right now? X squared minus 4. Is that a difference? Are they both squares? Do you know the square root of x squared? Do you know the square root of 4? Are they both squares? Oh my gosh, so handy. Check it out. Super easy. X minus 2, x plus 2. Every single time. Is it coming back now as we're doing this? Okay. Now, there's some other stuff that we're going to see. I don't know if you saw it in algebra last year. It could be a difference of squares. However, and sorry if the formation here, it could be a difference of cubes. Do you guys remember factoring stuff that looks like this last year? X cubed minus 27? It's okay. That's not for me to say, just for the record. I have no idea what you're talking about. Yay or nay, and this is where we're going to stop. This becomes x minus 3 times x squared plus 3x plus 9. Okay, we will cover those tomorrow. We're going to have a chill day tomorrow. You'll have time to work on stuff in class. You guys have a wonderful day. Enjoy your no homework. Hopefully you get some brain rest. I will see, depending, if it's a good game tonight, it probably won't happen. But I will try my best to make a flow chart that's just nice that I can hand out to everybody too. All right, later Raiders.